All right, and I think the stream is up, so we're good there. Open weather API?
APIs with open weather. Let's call it that.
I think that's how they do it, right? Do they do it?
It's openweather.com. I don't know if that's actually part of their branding or not, to be honest. That'll be more specific.
Is it Matt with 2 T's?
2 T's.
Times are tentative. Yeah, I don't know if those will be the actual times.
Flexible. So Matt, are you gonna play for us?
I'm gonna grab it.
Are you gonna play for us? Play music? Not today. Although, if you want to hear me, I'll be playing at the Gallivan Center on this Tuesday, or the coming Tuesday, and then the Tuesday, 2 Tuesdays after that.
Oh, really? What time?
7:30. Every Tuesday there's a big band in the summer, and so I'm in 2 of the big bands that play for that.
Well, that sounds fun.
Yeah, so and actually they teach dance and that, how to swing dance and that sort of thing before the concert, and it's all free. So.
Do they amplify or not?
Actually, I think they do, but it's for our bands. That's basically just like for the piano. So it's pretty acoustic. Yeah, we're not an electronic band.
So you have to advertise.
Do you think if I start 5 minutes early, everybody's going to be annoyed, or no? I think it's a thing 30-year-old Ferris would do, but not 31-year-old Ferris. So I'm going to go for it. Welcome. This is SLCPython. If you're looking for SLCPHP, that's not here. Just get out. Or if you're here for PHP, actually, let me show you something. Like, it's called Python. It's 100 times better. This is SLCPython. We are part of what we are starting to call, well, what we are officially known as is Utah Python. So Utah Python is a big, not really big, it's like 3 people. It's a non-profit that we started this year. And basically, the affiliation, or we are affiliated with that nonprofit, and that lets us do a number of things like have pizza and sponsors and all kinds of fun stuff, and it's tax-free for the sponsors. In addition, this lets us have a code of conduct for us to enforce amongst all of our affiliates. If you read the code of conduct, it's pretty straightforward. Don't be a jerk. Don't discriminate. That's pretty much it. That's literally it. And if you're a company that does either of those things, sorry, but you can't sponsor us and you can't post job listings. That's pretty much it. It's really straightforward. But yeah, that's what we do with Utah Python. We are a resource for any Python meetup, and we are looking for affiliates all the time. Python Utah North is going to be an affiliate. We are technically going to be an affiliate probably by the end of this month, August, as SLCPython. But let's talk about all kinds of intros. So let's talk about the other technology groups in Utah. There's the PyLadies. Anybody from the PyLadies? Heyo, party in the house. PyLadies is another national organization. They encourage more women to get into programming. They're not discriminating against guys. Like, men can go to the meetup too. But it's more focused on trying to empower women using code. We also have Python at the Point. Anybody from Python at the Point? Any Draper peeps brave the construction on the way up here? No? I know it's that bad, eh? But yeah, they are the Draper/Provo meetup group. So if you feel like driving southbound on I-15 during rush hour, they have really great meetups for you. Sorry? They're at lunch now? Okay, well, thank you for keeping me honest, Sean. So they avoided most of the rush hour that way. Although there is the lunch rush I've noticed that Lehigh starts to have.
Yep.
Yeah, Girl Develop It, SLC. Anybody from Girl Develop It? A little about Girl Develop It. I've conducted a workshop for them, but they're more project-oriented, workshop-oriented group. They're also trying to encourage getting more people into programming. They're always looking for volunteers. By the way, this whole thing's an Etherpad. It's linked in the meetup group. It was probably the latest comment in there. So if you want to add your own comments or write Ferris is a big jerk in there, everybody will see it. It's great. PyData SLC. They are a data meetup apparently that just started. I don't know who pasted this in, but somebody apparently pasted this in. Where's the data? Oh, here it is. I almost missed it. Data engineering. Who goes to that? I go to that. It's the only other meetup I go to other than this one, which shows you how much of a hypocrite I am. But anyway, yeah, that's a great meetup run by one of our co-founders, Joe Reese. He's focusing more on an emerging kind of role that he discovered, which is data engineering, and they're trying to make a professional group for discussing modern everyday data engineering topics. Really great talks there, really interesting people that you can meet. The last one, I think I saw you there, Isla and Jess, at Recursion, because you work at Recursion, but anyway. But yeah, they had a really excellent talk about Prism, right? I was going to say Snowflake, but it was a different one. It was Prism, and how to use Prism to model data across a bunch of different data sources, which is kind of cool. So you could run one query from a bunch of DBs, which I thought was kind of awesome. Yeah. There's also the language agnostic SLC Dev, started by one of our members here. I'm not sure when their next event is. All of this you can click on. The data engineering one is usually the second week, right? Of second Wednesday, third Wednesday? I don't know. Check their site too, because I don't want to falsely advertise. Yeah, websites / I guess Dylan decided this is a call to action, because we never update sites, right? I used to code for fun, and then I did it for work, and now none of my websites are up to date. And let's face it, when was the last time you published a blog article on your blog, huh? All of you. I'm looking at all of you. This is there's somebody in the back who's actually, I published this morning. Okay, good for you. Way to have your shit together. Not all of us have our shit together. Python Utah North, all of these sites, they need some help with development. So if you're looking for something as a summer project or something to build up that resume, we're definitely looking for people. All of these pull requests can be made to our GitHub repos over here. So /SLCPython, that's ours. Utah Python is Utah Python's. This one's written in Angular. No comment. I wrote it, so I can tell you that the coder did not know what he was doing at all. So, sponsors. Python East is like you. Thank you. Pat on the back. Anybody who's taken the opportunity to give that $5 donation, thank you very much. But just by being here or giving a presentation or just being part of the community, to me, that's a form of sponsorship. But money's better. But no, I'm just kidding. X-Mission is also a sponsor. They've been sponsoring our pizza for 2 years, some time now. University of Utah has been sponsoring the venue. Meetup.com via WeWork has been sponsoring our Meetup.com fee. We don't have to pay that $98 or whatever it is every 6 months anymore, which is great. Tech Systems has sponsored our prizes today. So these ones are sponsored by Pythonistas like you. So these are some of the nice things that we do with your money. I know, maybe not the best, but actually it's a lot of fun. So this one's Impractical Python Projects. Anybody read No Starch books, by the way? I'm a huge proponent of No Starch Press. Every time you buy a book off their website, so avoid Amazon, just go to their website, they will send you the PDF for free. Like, everything's included, no DRM, and they have a very open philosophy about their readership, and boy, are their editors strict. From what I was reading, like, they've sent back manuscripts so many times, so you always get a quality book that's easy to read and sit down. And quite frankly, some of these are really enjoyable. Like, this one's really good. They have a bunch of manga books that teach you, like, statistics or databases. Like, they're an amazing little company. We also have this 100-page machine learning book. This one just came out. I made it through 75 pages. I think, actually, let's see how many pages. It's 140 pages, so it's a bit of false advertising. Sorry about that. But yes, this is the 100-page machine learning book. And last, but definitely not least, by Tech Systems, we have these things. These are Pi badges. Everybody can see that? Okay. This is a tiny little full-color TFT screen that runs Python. I am also happy to announce that we have little lithium-ion batteries. Has anybody done hardware hacking before, just for fun? No one? Somebody? Yeah. So you may or may not know how tricky it is to build a charging circuit. This one comes with one, so you don't have to do any of that stuff. All of it's standard. You just use a micro USB, and you literally will copy and paste your Python file into this storage device, and it'll run it. It's kind of amazing. If you want more info about, like, Circuit Python, one of our former members, Nina, gave the keynote at PyCon this year, all about these things. And she's constantly posting blog articles on how to code on this. Yeah, somebody should post one and be like, hey, heard about this from you, Nina, and just tweet at her, and she'll send you a heart emoji. But yeah, this one's awesome. We have 5 RGBs over here. We have a bunch of buttons. Yeah, you can code whatever you want. So next Tetris game, or maybe like, oh, it also has a radio, so you could do like versus Tetris. So you could do your own thing with that. Lots of flexibility. We're going to be giving out 2 of these, and yeah, usually we just give out one, but it's my birthday tomorrow, so I'm going to give you all a gift. There you go. Yeah. New sponsors are always appreciated. Just hit me up on SLCPython, hit me up on Meetup, and we'll start the conversation from there. We are now tax deductible because we are an affiliate of Utah Python, so that's pretty fun too. Yeah. Sweet. So we like to do a new thing. Who's new here? Sweet. Now I've seen all your hands, and you're all going to introduce yourselves. See you all. So we'll just do a quick intro. So you're just going to say your name, what you're currently doing, and how you stay cool without air conditioning. I like to do a non-code thing. So I'm Ferris. I actually got a different job now. I'm now I'm on the data team now with Maria. Hi, Maria. And yeah, so I want to say I'm not a back-end engineer anymore, or a back-end janitor anymore, but I'm still a back-end janitor. I'm still fixing like code. So yeah, and then how I keep cool, I like to go with the old rag. So I carry this around, and I'll get this wet and just put it on my neck if I'm feeling too hot. It's a really good go-to. If you ever fly small planes, you'll find that there is no AC in those because it's just one more thing that goes wrong. So I'm telling you,
There you go.
the cool neck trick. So who else? You are new. Hello.
I'm new. My name is John Moose, and I'm the guy with the green apple. No, anyways, I just, my friend Corbett and I just did the Introduction to Data Science course here at the University of Utah this past semester.
Awesome.
So that I literally started Python from scratch probably 8 months ago. We did a really fun project.
What was the project?
We did we predicted California energy consumption using sklearn, MLB, and linear regression.
Nice.
And we like pulled from a weather API, dark sky API.
Nice.
So we're interested in kind of, I don't know, this is maybe about APIs, but anyways, yeah.
We'll see.
Students gonna be entering the full-time workforce here after this summer, and I take cold showers.
Nice. Smart. Corbett, how about you?
Hey guys, Corbett. You didn't know that. Yeah, I guess John covered a lot of it. So recently, I grew my hair out, and for all the guys in here, I'm sure you don't know this, but when you have long hair, it's like just having a welt on the back of your neck. It's totally what I'm talking about. So what I do is I just put my hair up. It's so cool.
Nice. Simple. I like it. Who else is new? John, behind you.
Yeah, my name is also John. John Sumlin. I work for Goldman Sachs National Institution, and I do a lot. And I've written a little intermediate script before we put it in a more enterprise application in Python, and a little bit of Go.
Nice. How do you stay cool, John?
I guess I would go stand in front of a fan, either south or the south of the studio.
Were you doing that a lot on Monday?
Oh yeah.
Because he's at Goldman Sachs and the stock market just went. Yeah, okay. Anyway, I had to explain my joke.
Right? Didn't it come back up yet?
You realize when it goes back up, it's going to take like weeks to go at this level to get back to where we were. We're at like January 2018 levels right now.
Oh, got it.
Yeah, it's pretty bad. Anyway, just don't look at your 401k. You will weep. Who else is new? This gentleman in the striped shirt,
Yes.
Kenny.
Yeah, Kenny Mills, everyone. Nice to meet y'all. From Atlanta, Georgia, and moved here about 2 months ago.
Sweet.
I guess I identify myself more of like a project manager. That's what I've been doing, and really curious about data analytics. So started learning Python a few months ago, and enjoying it so far. So I'm probably one of the main like rookies here in the room, but it's all good. And staying cool. So I got one of those like battery powered fans that
Yes.
like you always have to think, is it kind of worth like sticking out in the crowd by bringing this, and staying cool? So it's kind of a trade off, but I remember too. I try to bring it out there. Because
Nice. Nice. Who else is new? This gentleman in the teal striped shirt.
My name is Mike Will. Graduated last Friday with a master's in business analytics.
Nice.
Nice.
Yeah.
I have that one taken care of. A little more free time. I'm pumped to have a little more free time now for sure. We spent most of that up in the hills, stay cool. We do R coding in R, so I'm looking to branch out a little bit. So, and I've also got a project that's like weather and geospatial related, so there's a lot of ties.
Cool.
Excited to get into it.
There's a lot of meteorological people who are going to be sorely disappointed. No, I'm just kidding.
I was going to make that joke.
And how do you stay cool then?
Well, I got a little home cat. It's
A what?
sailboat.
What? A home cat?
Home cat. It's a little sailboat, so I keep that up at Rockport. It's like one of those parks and stuff.
So you sail to keep it cool? Is that what you're saying?
It's a cat. So yeah, it's a little cat.
Sounds bougie. I like it.
Those are people.
Nice. Who else is new? This gentleman behind you.
Yeah, my name is Abram Twitchell. I'm a current master's student in computer science here at the University of Utah, and how I keep cool. My apartment has a small cooler, so that's not what you see.
I guess that technically counts.
Yeah,
But
technically
you've got to work on that creativity, bro. Who else is new?
Sorry, welcome to my Druid County. First introduction to Python tonight from my husband. Seeing how we might be able to pull some data together with it. And to stay cool, as you can tell I'm wearing a jacket. I am cold all the time. So.
Nice. Nice. You got like an internal AC.
Yes.
I wish I had that. Ah. Who else is new? Over here.
I'm Tatiana. I work at Recursion with Ida and Jess, and they convinced me to come tonight.
Sweet.
I primarily use Python, so hoping to learn more things.
Sweet.
stay cool. I like to go to higher ambition.
Yeah, that's a go-to here. Which one's harder to work with, Isla or Jess? You can tell me. You
I'm
two
the
cover.
team with Isla. I haven't worked with Isla.
If you're saying Jess, I get it. It's okay. All right, who else is new? Right behind you.
Summer, I actually mostly work in design and marketing, so I've been trying to kind of expand into other fields. This is kind of an introduction to Python for me that a lot of you haven't worked with Python before. To stay cool, my nursing my daughter introduced me to frozen gummy worms.
You have a smart brother.
He is actually. He's awesome.
Frozen gummy worms, I like that. Nice. So, you're in design. I can think of, we have a previous talk from this group that was using Python to create art. And also, you can use Python to script 3D modeling with Blender. So if you've ever played with Blender or 3D, like, by the way, that was going to be my community news. Who else is new? Anybody? Did I miss everything? Great segue, because Blender just released their latest version, and it's usable. Like, it actually has like a nice user interface, and they made the Python scripting in it really easy. There has been talk about getting a Blender group going. Somebody on the Salt Lake City Reddit just randomly 2 weeks ago was like, hey, does anybody code Blender or know how to do Blender stuff? So we've been wanting to do that for a while. So if you know anybody, I have no like background in Blender other than random like stuff I used to make for 3D printers, but I know that that's a thing. Yeah. So that's the community news a bit, but we can also do quickly the who's hiring and who's looking. So hiring, We Company, aka WeWork, aka Team by We, aka Powered by, I don't know. They keep rebranding stuff, but anyway, it's the We Company for now. If you want to work with Maria and I, there's lots of interesting data projects we're working on. There's all kinds of stuff that has to do with like spaces. If you know somebody who's just looking to like have like a part-time job, essentially just being like a receptionist, they have careers like that too. So definitely check that out. For volunteering, my dad works with SCORE. They are a nonprofit that helps out small businesses. They're pretty fun. Fulcrum I left from last time. Does anybody know? Can anybody speak to them or no? No? Okay, I'm going to delete it then because that person's not here, so they don't get to. Loop. And then nobody's from Veterans First Mortgage.
That guy is.
Oh, that guy, Garrett.
Yes. Still looking for a position. Basically just someone with like a year or two of working in the industry. And if you have any questions, feel free to give me an email there. And I can send you the link with all the details. Or talk to me after this.
All right. And looks like somebody's typing in HireVue. Who's typing in HireVue? Oh yeah, you're at HireVue now. Because Matt used to be at Exhibition for like 15 years or something? 18? 19. Wow. He was only one day away from retirement. Just kidding. Now he's at HireVue. Do you want to tell us what HireVue is? And why we're not using HireVue to find people for HireVue?
Yeah, so HireVue is what you thought. You thought about using your platform? We did use it. I was hired using the platform. We talked, we did. It's a great platform for video interviewing and giving ethically sourced candidates because we avoid a lot of the human bias through data science. And we're hiring infrastructure engineers, among other things, so come work for us.
Awesome. Infrastructure engineers at HireVue to hire ethically and hire better. I miss doing your sponsored stuff. Anyway,
I have a question for you. I did an interview through the HireVue platform. Probably some pretty like deep stuff that you can figure out about an applicant, right? Can you tell how stressed I am on my applicant, or like how well I actually know if I like? Are you searching for kind of like that
How much do you know about him?
That-
That's what he wants.
that- I was just really curious.
Well, I'm on the infrastructure side, so
Yeah.
I look at the actual data, but I mean, there's some emotional analysis that goes on, but it's more about, I don't know.
You guys data processors or data controllers?
Serial killer and
GDPR. Who else knows of places that are hiring?
We're hiring 401go, 401go.com.
Nate
Yeah.
at 401go.com.
And obviously we do 401k software. 401ks are boring. No one should ever look at them, especially this week. So our goal is to make it so no one ever has to look at that 401k. It's just done for
I
them.
like that. Sweet. Anyone else?
University of Utah Health is hiring for my old position. So that's basically a database, what do they call it, analyst or something like that. So if you have any questions about it, you can ask me too. I'm very unbiased on the system, I suppose. And then my new company, Community Data Platforms, is hiring several things. So you can just go to the website and see what's the project manager, and I think you might be hiring a programmer too.
Community what?
Data platforms
And they're remote.
and full-time remote. You get to work in your pajamas.
I mean, I do that anyway, but
Are you going to stay cool in your pajamas?
Well, I got
Carefully.
short pajamas.
Okay.
The most wonderful part about living in the 21st century.
yeah.
Oxymoron, right? Short pajamas.
Who else is, before we dive into this conversation, anybody else who's hiring? Anybody? Going once? Going twice? All right. Sounds good. Who's looking? Oh, did somebody? Oh, looks like a couple people put their stuff in. Todd, you put your stuff in. You got to stand up.
That's fine.
Got to market yourself.
My name is Todd McDaniel. I've been a system administrator for 20 plus years, most recently here at the university. I've also spent about the last 3 years primarily doing Python, and I really prefer that to doing system administration. So my GitHub link is up there, several projects up there.
If I recall correctly, did you write a front-end desktop application using TK-Enter?
I did a
And he did a talk, and it was amazing, and I highly recommend everybody looks at it, because that's one of the few talks we've had here that wasn't web or data science, and it was actually, like, effing cool. Like, it was really cool.
Thank you.
Yeah.
I want to hear about Lazy Mutt.
Lazy Mutt?
That was just a nickname that stuck.
Yeah. Like, people like Todd and I should not come up with GitHub nicknames. Like, mine's terrible. I came up with mine when I was way too young. Carrie! Hi, Carrie! I was looking for you.
Okay. My name's Carrie. Some of you may know me as the pyrogeographer of the group. I've transitioned into data analysis and data science. I just really like it. Like, I'm good at Python, and I did a lot of R in college or for grad school, and I took a lot of stats classes. I'm kind of good at it. So so a contract brought me to Salt Lake, federal contract. Was a Python developer and DBA, and that ended. I've just been picking up some like random freelance work and like traveling a bunch this summer. It's been awesome, but now I kind of need to get a real job. So that's fun now.
Sweet. If you would like to hire a former pyrogeographer, Carrie, which is still the most badass title. Like,
That's true.
ugh.
I wish I could put pyro in front of my job title.
I
Probably just make it sound cooler.
I'm going to. I'm just going to do it.
Just do it.
Just do it.
I know, I just don't
Pyro
do much of it
senior
anymore.
software.
That's the thing, it's all in Python, but I love Python data analysis. I just don't really work much with maps and wildfire. That's okay. But if you want to talk maps and wildfire, I can talk it.
Sweet. Actually, I'm sure there's a lot to talk about because, it's summer in
Yeah,
Utah. So
I know.
there was a lightning storm on the weekend. So there's probably lots of fires still going. Sweet. Anybody else who's looking and willing to market themselves? Going once, going twice. All right. Community news. There's less than 5 months left to our equivalent of Y2K, aka Python 3. It's going to be the thing, not a thing, the thing. Like, if you try to apt install Python, you're only going to get 3. If you try to look for Python 2 stuff, Google will be like, what are you doing? You should be on Python 3. Just saying, be careful. Make sure that you have something in place to get to Python 3. Other community news, the new Blender was released. Okay, and any other community news like local community or tech community, something cool happened? Anybody remember anything? For once? Twice? No? All the devs are on vacation, I guess, so there's no big releases. All right. Sweet. New topics, speakers. If you have one of these, just let us know. You can just put it in here. Did anybody have like a talk or something in mind for September? No? Oh, okay. Well, and if you think of something, come up after the talks today, and I'll get you down. And if you've never done a talk, I will mentor you, mentor this guy over here. And yeah, you'll rock it. One more point of order. Our next meetup is the 3rd of September, right? I think, or is it the 5th? Can somebody look that up real quick? The first Wednesday, is that a 4th? Four? Okay. I had a question. Would anybody like to try doing this meetup downtown at the Gateway, just for once? Who would be completely against that? Nobody. And you can raise your hand, like. Okay. So the only thing the biggest difference is parking's free. And the other thing is that a new WeWork location opened there on Monday. And because I'm an employee of WeWork, I can just say, hey, I want to have a meetup here. And they have to set it up because WeWork also owns Meetup. So it would be quite hypocritical if they said no. But I already checked today, and they're totally keen on it. It would be about the same time. Extra amenities we'd get would be like, if you've ever been to a WeWork, they have like the ice water with fruit. It's really nice. And like coffee, which is amazing. And it would probably still be the pie pizza because they deliver downtown. If it's not the pie, I will get the pie hole because the pie hole is amazing. So, yeah. Are there any vetoes? No? Okay, let's aim for WeWork for the next one. I'll let my contact here know. All the recursion people are like, yeah, let's do that because they're like right next to the new location. Yeah. Do we get a tour of the climbing wall after or no? Yeah, cool. So in case you don't know, if you're like OG Salt Lake City, or OG Utah resident, and you remember like the Gateway when it was like in its heyday right after the Olympics and all that, does everybody remember like Dick's Sporting Goods and that giant climbing wall? Mm-hmm. Now imagine you're a pharmaceutical company and you buy it all, and you're like, because there's no more Dick's Sporting Goods, and you're like, we don't want to move this giant climbing wall, and like, yeah. We have a slide at our startup, and they have a freaking climbing wall. So, I mean, it's awesome. But yeah, it's really cool space. Yeah, the Gateway's coming back. I hope. I don't know. We'll see. It would seem I've been up here too long, so we'll get started right now. Matt, do you want to take it away? For people who don't know, Matt is a badass. That is his title at work. He also... This is his first presentation at this group? Yeah?
Yes.
Yeah, so he's going to be showing us all about open weather using Python. And if you are following along, feel free to make notes down here, and people can make notes with you. So without further ado, Matt.
Is that display port?
Do you want a display port?
I think that is what I have. Yes, I have display port.
Okay, one sec.
I guessed poorly. I looked at it, I'm like, yeah, that looks like just like a display port.
I think that, nope. The one that I don't have. I'm sure I have it somewhere. Come on, buddy. Yes.
All right. That's a. I think that. Oh, that's a mini display port.
Jeez.
Oh no.
Oh, that's not good. Does anybody know how to use a computer?
Oh, shucks.
Let me see.
If you just point me to the repo, I can use yours if you want.
Yeah, but if we do that, Kirkwood's going first.
Fair enough.
Yeah, Kirkwood, you're going up.
Okay. Cool. Your famous last words a moment ago. I have everything.
Huh?
You said you were like, I have everything.
I thought I had everything.
Yeah, so excited about what.
And I normally put it in my bag.
Yeah? Oh, that's okay. Yeah, see, that's the death clock. It was less than I thought. 4 months, not 5.
Well, almost 5 months.
Well, I mean, it's almost 5 months, but you need to tell your project managers that it's like 3 months, okay?
You need to tell your project managers it's already done.
Yeah. Is it the one you emailed me?
Yes. I've made some changes, but as long as it's the recent one from yesterday, then we're good.
Do you know how to make it maybe high resolution? Or like setting on my computer?
It should be a display
Or is-
setting.
Yeah, just go to displays. Yeah. It's probably, yeah. And then you say scaled,
Default for display.
scaled, and then 10. Yay, I still know how to use Mac.
That looks cool. Okay, cool. Let's see. Let's look at that.
I don't know how to do this.
Totally setting here.
Do you want to switch places with me?
Sure.
Hopefully I don't disconnect every... Oh, crap. Okay, good. There's too many wires with this setup.
Sit back. Single page. Cool. Okay. Hey, my name is Kirkwood. I'm a data analyst. I work at Overstock, work on the search team there. A couple years ago, I did a data science bootcamp at Galvanize, and I did a presentation on boosted trees. So I originally signed up for random forests, and I will touch a little bit on random forests in Python, but I sort of was going to back out of it for another commitment, and then the last minute that fell through. So I decided to give the presentation I've given before, and skip over some of the details, and then get into the Python part, because we're a Python meetup, and I don't need that. So boosted trees. Boosted trees, boosting is an ensemble method, just like random forests. So for show of hands, could I get a sense of who in the room feels pretty comfortable with like the theoretical underpinnings of random forests? Show of hands here. Okay, about a quarter. Okay. So I'm gonna open up a web browser because I just want to talk a little bit about what these methods are doing. So I'm gonna how what is a random forest? So both of these methods use something called a decision tree, or many decision trees. That's a good example. Not a great picture right there. Oh well. Let's pick something. So a decision tree is it's a piece of data, or it's a model. So you take some data. Let me blow this up. Open in new tab. Open a new tab. Okay. Anyway, so one of these here is a decision tree. So basically, the way that a decision tree works with data, we can all make decision trees on our own. So say we're talking about the Titanic and whether or not someone died, which is morbid. So there's some things that we might know about each person on the Titanic, like how old they were and what gender they were, and maybe what compartments they were staying in. And so we can make a decision tree and say that, okay, well, are you male or female? More males died because often females got on boats first. So that might be a good way to split up data and say that, male, female, you're more likely to live, and male, you're not. So what a decision tree would do is okay, male, female, are you below the age of 5? Are you above the age of 5? It would split the data in various ways until you get until you run out of information in the data to make these types of predictions. So the way a computer builds the most efficient decision tree is by using something called an information criteria, by optimizing information criteria at each step. So it'll find like the best age to split people at, so that when we split the data into those two groups, now we've gained the most information about conditional probability of whether you've survived at each step. So a decision tree, the advantage of it is it can, in some cases, completely explain your data set. So it'll just find the best ways to split it up over and over again until at the end we have a very close estimate of whether or not this person, based on these data, survived the Titanic. The problem with this is that in machine learning, as you might know, we're looking to make a prediction about new data. So if you have a decision tree that perfectly predicts some data set, then you introduce the Lusitania, which was also sunk in the sister ship of the Titanic. It's not going to perform as well because it makes a bunch of assumptions about the specific data that existed for the Titanic. So what we call that in machine learning, we talk about that as being a low bias model, because the model very closely represents what the data are, but a high variance model in that if we introduce new data into the system, if we train it on another data set that is the same population, we're going to get a wide variance of models. The model is going to change radically based on which data set we're using. So the way a random forest approaches this problem, basically the problem with the random forest is overcoming. The problem that it's overcoming is the decision tree is too specific. It basically describes the data way too well. And so what we do is we do various things like limit how deep the tree can become, and how many variables and what data we use. We sample the data and basically create the random forest part. The forest part is creating thousands of trees. And so we create all these trees, and then at the end we predict with all of them and aggregate the response in some way. And so that cuts down on this variance that occurs between trees by averaging it out, basically. So boosted trees, in contrast, let me find my presentation. Boosted trees, in contrast, are doing it in the opposite direction. I'll explain that in a second. But anyway, the goals that I want to I'm going to quickly run through this presentation because this is for more theoretical, and I want to get to the Python part more quickly. I'm not going to talk about the boosting or the algorithms that you use to create boosted trees, but I do want to compare and contrast boosting versus random forest. That's probably the only goal I have, is to compare and contrast those two, and talk about what boosted trees are like. If we were all a random forest, all of us in this room, and we were taking a test together, the way that we would best represent being a random forest is that I would give each of you an exam, and you would fill it out, and at the end of the exam, we would take all those answers and aggregate together. And then that would be like the random forest taking all these predictions from all these trees and averaging together. And then we'd have a really good, probably, prediction of what the right answers are, because I might be not good at APIs, but you are, and so the question, you get the API questions, and I get the search questions, and I don't know. And overall, we're going to get good answers, and then that's our prediction. And this is talking again about the difference is high. So a random forest is very low bias, but with high variance between us, because our answers might be varied. It just depends on our background and knowledge. We're going to vary quite a bit. So another way to approach this problem is instead, what is your name, sir? Mercado? Ricardo. Let's say I gave Ricardo the exam, but I say that you only have 1 minute to answer the questions. So there's 100 questions, and I give him 1 minute. So Ricardo does the best he can to answer the questions, and then after a minute I snatch it away, and I mark off the ones he got right and the ones he got wrong. And then I pass it along to, what's your name? Matt. Oh, that's right. You don't have a name tag. You're not gonna have a chance to win these things. You would have a name tag. So I pass it along to Matt. So Matt answers quickly. Maybe he jumps to the API question because he knows about APIs. And so he answers that one really quick because he only has a minute, and I take it away, and then I move it on. And we just move through the room like that. And basically every turn I'm scoring the test to tell the next person what was right and what was wrong. So as you can imagine, as we go through the room, eventually what we're going to end up with is a really good test. So what we call these are all weak predictors. So they're all weak estimators. If you have a minute to answer a 100-question test, you're going to do really poorly on your own. But if each of us has a minute and we get to build off of the last person's answers, then we're going to do very well. So that is essentially, that's the intuitive difference between random forests and boosted trees. Yeah, I guess we call it boosting or boosted trees. And the boosting is in between, well, it refers to an algorithm. I'm going to take that back. So basically, it's strong learners all taking tests and aggregating answers versus weak learners building off of each other until they become strong. So they both of these methods arrive at the same conclusion of having low bias and low variance through the aggregation of multiple estimators. The boosted trees, the way they would actually work is instead of having, like, you can split on as many data points as you want, you just get to pick one data point to split on, maybe. Who survived the Titanic? Are you less than 5 years old? If you're less than 5 years old, maybe that's the best, maybe that optimizes the information criteria that predicts best whether or not you're going to survive or not survive. So if you're less than 5, you survive. If you're over, you don't. That's probably not true. But then we pass those, basically then we take that, pass the data through there, and then we look at the errors. And we see, okay, which ones are erroneous? Okay, let's have the next tree predict the next, based on those errors, what one choice can I make to make the next best split of the data and get the best prediction. Yeah. So in other words, you start out with a model that really doesn't represent the data, and then over time it does through many, many iterations of weak learners that don't represent the data very well, arriving at something that actually predicts quite well. Are there any questions? It's kind of vague. Cool. So we end up with low bias, low variance. Very important. I'm not going to make you do that. Cool. There are a couple algorithms. I'm not going to go over them. I'll post this presentation if you want to look through them. The math is cool if you like to think about math and algorithms. There are just various ways of accomplishing this task. The important part I want to talk about is intuitively what this might look like for data. So a boosted tree algorithm, it's going to take step one here. We want to classify blue and red dots in this case by splitting on x naught and x1. And so the first choice might be to if you're greater than 0 in the x1 dimension, then we're going to say you're red, and if you're less than 0 in the x1 dimension, then we're going to say you're blue. But of course, then we're going to miss these, and we're going to miss those up there. This is specifically trying to represent one of the algorithms. That's why the dots are getting bigger, because this algorithm penalizes increasingly over time the ones that the trees miss, so that they're more likely to make deviations to capture those points. But the point is here that each turn we get another choice to make, where we can be like, okay, yes, if you're above 0, less than 0 x naught, but also given that if you're greater than whatever, or less than negative 0.5 here, then we're also going to say you're red to capture some of these over here that we missed. But that doesn't quite do it because we still have some red that we're predicting to be blue. We have plenty of blue up there. So then next step, we're going to be like, okay, yeah, but, and I think this this graph, as I remember, is not quite representative of what would be going on because it's just adjusting upwards. But anyway, the point is that each turn we get another chance to make another prediction, and each prediction is not that great, but over time we're going to end up with classification in this case that predicts well blue or red. And this is kind of a complicated problem because the data points are mushed together, so it's not a clear linear split that we could be doing. Otherwise, the first step would do just fine. We just split it in half and say red or blue. So that was a classification. This is like a mock classification problem, or classifying red or blue. But boosted trees can also be used to as regressors and produce like estimate or predict a model for data that is continuous. So in this case, we're trying to understand what the signal is that produces this data. So in the first step, we're going to predict like a linear line through 0. But that's a pretty biased representation of what this is like a. I should have Googled this. Does sine go through 0? I can't even remember. Is it a sine curve? Can I call this a sine curve? Okay, great. So this is a sine curve. A line through 0 is not a great representation of a sine curve. But then each turn, every time we're going to take the residuals here and say like, okay, these are really low, these are really high. I'm going to for this group of data, I'm going to split. I'm going to estimate a little lower here and a little higher there. And when we go through thousands of iterations of these boosted trees, we're going to end up with something that's like, okay, well, if you're between this step, you're here, and this, you're here, and then over time, it's like making all these splits of the data until eventually we end up with something that looks very close to the theoretical underpinning of the data set, which is pretty cool.
Is there anything that you would do to avoid overfitting that, or?
Are you? Let's see. Let me think about this. I'm gonna have to like get back to you on that, because I do recall that like random forest has have a problem with overfitting, which it handles by just sampling of the training set and limiting like depth. Yeah. So in this case, as I remember, boosted trees just have less issues with overfitting because they're so stupid in between like steps. So they're just like they're not gonna. But that's a funny answer, but I don't know I can't recall the real answer. Does anybody know the answer to that question?
The gray points or the smooth curve?
Referring to the purple line, but in general.
Yeah, is the truth that you're trying to match?
Oh, the truth is black.
Points, because then you do avoid overfitting, right? You could imagine fitting like getting a curve that's like jumping up and down at each point and trying to hit all those gray points.
Mm-hmm.
But if you're actually just fitting to that like smooth sine curve. I'm not sure like what the label is in this problem.
Well, the label is there are no labels. It's just residuals.
Gray points. That's what I assume.
The gray points represent your sample. Yeah, and the black line is the model that was used to generate the points, and it's just showing like what it would look like with some random variance. So in this case, it's not overfitting because. It is not trying to capture every additional point. So there must be something, and I don't recall, in the algorithm that's boosting that prevents it from, at some point, it's just not gaining extra information, and so it's not going to say, it can't fit a lot of these like too much. There's a certain amount of variance here, and it's just gonna say like, well, this is the average. Here, and I'm just going to stick with that, which is, in this case, correct, and not overfit. But yeah, I'll have to think about that. I don't know. If anybody has some thoughts on that, feel free to share. Okay, cool. So that should give you like a good intuitive sense of decision trees and random forests. Hopefully that wasn't too heavy. Anyway, so if you want to, you can open up this really cool website called, there's the countdown clock. Collab.research.google.com. I learned about these at the last meetup, and I think they're really neat. So basically, this is IPython notebooks within Google's infrastructure. And they give you cloud computing resources, so you don't have to use your own computer, which is really neat. No, that's not what I wanted. Let's go back. So if you're on this screen, introduction, here's my stuff. You can go to the file. I think it gives you options down here to like open up a new notebook. But if you kill that screen like I did, then you can come up to File on a new Python 3 notebook. I'm going to open up one I've already created, so I can follow along with that, but you can follow along with here. Collab. Anyway, yeah, you can create a new one here when you come to the website. Boosting, that's what we're doing. Okay, cool. So I'm just going to import some libraries here. We got NumPy and Pandas. Those are super standard for data science toolkits. Yeah, probably. I'm going to sit this way so that not awkwardly look backwards. Yeah, probably. Let's see. That works. Awesome. Does that work?
Yeah.
Yeah. Cool. All right. Cool. So we're just going to find some data. This is some data that I've used before. It's a housing price data set. So all you have to do to load it is load Boston function from datasets, which is pretty neat. And then you have this funky object that you have to transform. Inside Boston data is the data, and then feature names are what they're actually called. So I collect them together into a data frame here so that we can just look at them. But you can see there's I believe this is maybe neighborhood level, or yeah, some kind of neighborhood level. We got all kinds of stuff in here. Or is this person level? No, these are averages. Yeah, so we got crime, and this is some kind of industrial metric, and average age perhaps, something about taxes. Anyway, so these are features that come along with this data set. And what we're trying to predict, I think, is housing prices. So if we, not Boxton, that's cool. So if we look in here, it describes some stuff. I think this is like a big text thing. But anyway,
If you print it, it'll look better.
Oh, really? Cool, okay. All right. Oop, frame. Ever since I took my first computer science class, because we wrote Hello World so many times, I now have trouble writing hello without a W on the end, because I was so used to writing a W after hello. And I, for some reason, I have the same problem with print.
Thank God I'm not alone. I don't know why I do that.
Hello. Yeah. Anyway, yeah. So the target variable in this data set, so somewhere in here, is housing prices. Yeah, Boston house price data set. Oh, now we can learn all about what the level is. I guess this must be. This is a copy. Okay, it must be, there's only 500 observations. I feel like it's a neighborhood level. So we got some stats about crime and wealth and various other things. So we're going to try to predict what the average price of homes are in that neighborhood based on these data. So I'm going to get rid of that. Cool. So we need some stuff in here. So from sklearn.ensemble, so we talked about these are ensemble methods, and as so named because we're taking a bunch of decision trees and we're aggregating them together to get our good predictions. Ensemble, and we're going to import the gradient boosting regressor. And regressor, we're picking regressor, and so there's also a classifier in there because we're predicting a continuous variable. If we were predicting like the color dots, then we would pick the classifier instead, or something else, something categorical. Anyway, so we need to import that. We need to, I'm going to pull in these things so that I can quickly do train test split. When you do machine learning with sklearn, you're used to importing these things because they make splitting up the data set very easy. I'm going to pull the Boston data and the target variable, which is here, into X and Y. And we can look at Y. Oh, there's some comments and stuff on. So yeah, so these are, I guess houses are really cheap in Boston because they're only $21. So if you're looking for real estate investment, pretty good. But these must be in some
100,000.
100,000, yeah, I don't know.
240,000 now.
It must be something like that. So that's what we're trying to predict. It doesn't really matter because all we're trying to do is see if it can predict it well. The train test split function takes your x and y, and you tell it what proportion of the data set you want to be your test set. That is I think that's for the pseudo random number generator. And then when I run this, I get training and a test set. So when I'm building this gradient, this boosted tree model, then I'm going to instantiate it. So I pulled in here. This is talking about what the loss function that we're trying to optimize for this model. I'm sure there are other ones, but this is the least squares version of it. So we're trying to optimize least squares. This is how many of those stupid little trees that we're going to build to put together to make a smart tree, and then a random number again. So that instantiates this as an object, and then really, sklearn has limitations, but it's very simple and its syntax. All the models are the same. So you just pass in your training and your training set into the x and y parameters here for this function. So now I fit the model. Now the model has been trained on these data, and it ran really fast because there's only 400 data points in here. And then, what am I looking at here? Predict. Yes. So now, if I take GDBR, my boosted gradient boosted regressor tree forest thing, and then I run .predict. All it takes is a test set. So you just give it the test data, and then it's going to make a prediction for those data points. So here I'm going to pull that out a little bit so we can just see what that looks like on its own. I'm going to get rid of that. So here we go. There's a bunch of prices, kind of like we were saying. We're within the neighborhood of what we would expect. To make it clear about like how far off it might be, I put them into a data frame here, pandas data frame. So you can write pandas data frame, and pass it the prediction here, and then this is what it actually was. So we're testing it to see what it looks like, and we can see that when we put them next to each other, it seems to be doing something pretty well. But if you're familiar with testing or testing the performance of algorithms, a good way to do that is take the mean squared error for the model. So for this test set, and we have cross-validation is really important, right? And then also looking for the optimal number of parameters, like how many trees you should use and which loss algorithm is the best. So you can test. sklearn has lots of tools for like iteratively testing lots of different options against each other and seeing which one is the best. But we just picked stuff here to keep it simple. And this, so here I'm going to take the prediction here from my x-test. I'm going to subtract off the actual and square that. So that's the mean, that's the squared errors. And then I'm going to take the average of that. So that's the average squared error for this model, which is a standard way to measure a continuous a regressor model. Okay, so then we have this number, which means something. It's a squared error, so it's like the root of that is about 3, or a little less than 3. So that's the average error we can think of for this model for whatever those 20-something, whatever that unit is in terms of housing prices. So quickly, we can compare this to a random forest model. So very similar thing from sklearn Ensemble. We have random forest regressor. Also have a classifier in there for reference. I can build it very similar setup. I'm gonna build 100 of these very smart trees and then get them all together and aggregate their response. Number of jobs. I don't remember what that parameter does. And then I'm gonna fit our training sets in the same way. sklearn is great. And we're going to look at, well, you can already see what's going to happen. So that would give us the prediction, which we don't care about anymore. And here's the mean squared error. So this is just like a really quick comparison. Now this is just for this single test set. So what you actually want to do in real life is cross-validate. You want to create, many test sets, maybe iteratively across your data set, and then compare the average results of the mean squared error in this case. And then you also want to test different what we call as hyperparameters, which are the what we use to control how many trees there are in this case, or how deep the random forest can go, how fit it can be to each of those training sets. Yeah, so that's all I have. Any questions about that? Twisted trees or life? Cool. Thank you.
Right. Let's set this guy up. Thanks again, Kirkwood.
You're welcome.
So I guess you're using my machine?
I guess so. That's the real reason I forgot that adapter, so I could use a sweet System 76 machine.
Yeah.
I have not yet, but I just started using it.
Let's see. All right. We probably, yeah, it's on this side. Yeah, we probably should, plug it in.
Yeah.
The whole point of this.
Let's see here.
Do you want to mirror the screen? Would that be easier?
Yeah, that would be easier. Yeah, okay. You have to do that better than me, I'm assuming.
Yeah, I'm trying to remember how to do it on this machine.
Oh.
Sweet, that did work. Awesome.
Where's my project?
Oh yeah, you probably don't want to see.
Yeah, that's probably proprietary.
It's not. It is, but I don't care. And this one. Oop, that's recursive. Oops. There we go. Yeah.
Yeah, there we
it's
go.
with Vim bindings. I can turn off Vim.
That's fine. Yeah, Vim mode is fine. Just check to make sure it runs. Oh, let's see here. I'm in the wrong one. Oh.
No module named Panda.
We don't have any. I'll just install that real quick while I get started. Oh.
Where's what? It's also I3.
Seems to be.
Yeah, you'll have to hold the meta button and then move it.
Oh, okay. I was gonna say it's off the screen.
Yep.
Okay, let me just put that on there. Okay, I think that. Hopefully that's all I need. Oh, how do I close the window in i3?
Look at that.
Okay. Well, hopefully that works.
Did it work?
It has to install the pandas. Oh, okay.
That's fast, remember?
That is fast. Okay, perfect. Yay! It works.
Woo! Okay.
All right. So sorry for the technical difficulties there. That's what I get for playing along with my old employer and giving them back their adapter. Yeah. So I'm going to just talk a little bit about using APIs. I'm incidentally using the Open Weather API, so unfortunately for all you people who actually know things about weather, it might not be as interesting as you were hoping to. But so this is geared more towards, and going to dovetail with what Ferris talked about last time, which is a lot about, he was talking about beginning Python. This is like the next level. You know the syntax, that sort of thing, but you want to get going into doing something a little bit more advanced. So I'm going to talk about using an IDE and that sort of thing. Pulling in data from this API and like I said, so it's going to be an intermediate type project. So why don't I start by telling you a little bit about, so last time Ferris mentioned that you probably want to start with a notebook with new students, and that's probably true. They're a lot easier to get going, and as we just demonstrated, like you can use notebooks for pretty much like an entire career because they're awesome for a lot of things. For engineering, it becomes a little bit more difficult to manage something like this. So right now, the file we have up here is only a couple lines, but if we were to take all of the code in this entire project, it would be like multiple thousands of lines, I think. And so stuff becomes relatively difficult to keep track of when you have something that's, you're trying to engineer. And so that's where an IDE comes into play. So the one that I generally use is PyCharm, and that's, fortunately, Ferris has that installed in his machine as well. And so the way this works in the top left corner, sorry? Oh yeah,
I'm not sure, is there something I can do on i3 to make that bigger?
No, just the font.
Yeah, is that?
Control Shift plus. It shouldn't be an i3.
Oh.
Okay. Who knows PyCharm better than
I've never had to make the
one
font
of our
bigger.
members literally wrote the book on PyCharm.
Oh, really? Oh.
Yeah.
Okay, well, I'll go back and forth between that then, because I'm going to talk a little bit about the layout here. So we can see in the upper left corner here, you don't necessarily need to see the text specifically, so my apologies if it's a little bit small, but when you're on a laptop yourself doing the work, it's not quite as bad. This is the basic structure. So there's some stuff that you can just sort of ignore, like the .venv is just where the virtual environments are stored, and the .getignore is just for Git, so it doesn't put files up there that you don't want to be up there and that sort of thing. But this really helps your organization. So you can, if you can't read that, I have 3 folders in particular. One is database, one is module_OWM, and one is requests OWM. So these are basically just controllers for the various parts of my project. So what we're going to talk about tonight is how to put data into a database, and then the other part is how to pull stuff out. So I've separated those into their logical subcomponents so that I'm not cluttering what I'm working with, because otherwise I'd be trying to deal with all of the code all at the same time. So that's one of the benefits to using an IDE. So when you're talking about pulling data from an API, there's generally 2 ways to do it, fortunately, because in Python, everything has been done for us in a lot of cases. So the requests, the module OWM folder here contains all the code that you would need using a module called PyOWM, which fortunately someone out there just went ahead and said, oh, hey, look, the PyOWM or Open Weather Map has a really cool API. Let me write all the wrappers and stuff and take care of all that stuff in the back end so that nobody else has to deal with it. In the case that hasn't been done, you'll have to use a module called requests, and that sends basically a request to the server that you're trying to get data from, and then it pulls it back as the actual request object, and it's a little bit complicated. I'm going to just stick to PyCharm for this because I'm not as familiar with controlling it, but the basic idea is if you go to a website and they have an API, you can usually figure out from the structure what it is that they're trying to give you. So let's start there. Okay, where is this presentation mode? Oh. Okay, there we go. Okay. So I'm just gonna sort of skim over how we get credentials. So essentially, when you're using a service that like a website like Open Weather Map, you're gonna have to get a key from them that says, hey, this is who I am. It's gonna uniquely identify that like you're the person actually pulling in the data, and that helps keep track of stuff on their side, because otherwise they could just be sending someone who's just going to download everything. So in order to put limits on what you're downloading or to keep track of who is a customer who's paying for certain services, they'll give you a key. And so that's what I'm going to put in here. So on the Open Weather Map website, basically there's going to be a API documentation, and it's going to say, hey, go to this URL here, weather, ? And feed us this key that we give you, and give us a city ID, and what I'm going to give to you then is weather data. And so that's what this is doing here. So we can see that I'm giving it a string, and I'm using interpolation here, .format. So what that does is it puts the ID that I'm going to give to it and the key that I'm pulling from some other function that we're not going to deal with. And then request goes in and does a .get, so it goes to the server and says, hey, here's a string. Go ahead and fetch me whatever it is that you're supposed to get on the other side of that. And so I'm going to, let's see here. Oh, I'm in caps lock. Ferris, is there something you do to get out of caps lock?
Yeah, hit escape at install.
There we go.
Because caps lock is way too big for what it does.
It is. I usually revamp that to escape for me.
Yeah.
Okay, equals. So what we're going to do here, I'm just going to copy this real quick so I can show you what that looks like. Let's see here. Insert. Oh. Okay, there we go. I see. I'm getting the hang of your machine. There we go. Okay, so. Oops. So here we are going to send Open Weather Maps a direct request. Oh, no, we're not. Now we're going to send it a direct request. Yeah, so we can see we got this response 400 object. So this base 400 is just a response that says, hey, I got your stuff, here's what it is. So we can dissect that a little bit. Yeah, so if you do a dunder dict, that's what that's called when you have 2 underscores, it's a dunder. Let's see here. Oops. Ugh. There we go. So this is the object that we just got back. So we can see that oh, actually, it's giving me a little bit of the key there. So oops, don't steal it from me. That's my Open Weather Map key.
This isn't being recorded. Oh, wait.
It's okay. It's truncated. So it's like, if you can get the other half, you're a better, whatever it is. Yeah, you've earned it. Yeah, so we can see here that there's some stuff that's probably not super useful for a lot of us, but let's see here. What did I do here to get rid of this? Yeah, so all you have to do then is send it a decode object. Object. Oops. There we go, and this is going to, oh. So I have something up here that parses it, so we're just going to go through that for a second. Content.decode. Oh, shoot. Ah. Okay, well, at any rate, so I'm going to just call the function that I already made, because why wouldn't I call the function that I already made? There we go. Oh. Oh, that's funny. Well, at any rate, so this is sort of unimportant because you don't have to do it this way, but if you go through my code, it will give you this, basically this content object, you decode it. For some reason that's not working, but that's what you get for live coding. And so essentially here, it returns exactly the same object that we'll get later. And so what I've done here is I've just parsed it into the various content that you can actually get from this, and this is all documented on the Open API. So this is the not so fun way of doing it, so let's go through the way that actually is a little bit more fun here. So this is the cool part about Python. Stuff has already been done for us. So, okay, there we go. Where should I start here? Okay, so the way that PyOWM, which is the module that I've used here, work, and you can see that no, you can't because it's too small. At the top there, import PyOWM. So that's the module that someone has awesomely wrote for us, so that we don't have to go ahead and do all that stuff that I just did in the other, that other file there. We can just go ahead and pull data in straight from the API using all object-oriented stuff. So let's see here. So you can see here I have a function that the OWM_connect. So this just takes that key and we send it off to OWM and it validates it for us, and then from there we can get all sorts of fun stuff. So what I'm going to do, go back to the front here. So what I've done is I have a main script, and that's, so this is where, if you were to run this, what it's going to do is it's going to pull in all the weather for all of Utah right now. And so let's see here, save Utah weather. So I'll just walk through that. Oh, let's see, Vim mode, slash, right? What do I call it? Oh, I thought that was supposed to be find, but I guess not. Oh, because I'm the wrong one, that's why. Okay, there we go, okay. So the way that I do what I just described, where it goes and gets all the weather, is I've broken this down into functions. And this is another good thing to do, or to get used to if you're going to do basically any kind of engineering, is to break things down into simple steps so that you can test every individual component. So in this case, I have a function called get OWM IDs by state. So that's just in the same file. And so this file is going to contain all the stuff that is using this particular Python library to query data. So right here, this is a very simple function. It just takes an OWM ID, or the OWM object, which we're going to get from OWM underscore connect up there, and then the location. So in this case, actually, this one takes a name. There's one that's by weather ID that's right below that, and so that takes an ID. What Open Weather Map does is they assign a unique identifier for every weather station that they have, and there's one limitation to that in that it's only done, if you can see by here, get OWM ID, they only take a city name. So I'm from Morgantown, West Virginia. There's also a Morgantown, Pennsylvania, and a Morgantown, Texas, and a Morgantown, Iowa, and there's like a bunch of Morgantowns. So if you put Morgantown there, you're going to get like 12 back. And the only way to identify that is by using latitude and longitude coordinates. So that was an interesting choice by them. So if you go to the code that we put on GitHub for the Utah SLC repository, I've actually just went ahead and cheated for you, and I put a CSV file that just has all of the stuff in Utah. So you don't have to do that, because otherwise it's a very convoluted process to get from point A to point B. So yeah, so with that, WM IDs by state. So basically this function, what I'm saying there is this function's already done for us. That's not something that's part of OWM, but if you wanted to use OWM at the state level, you would have to basically come up and figure out what are all these IDs, but we're just going to pass that. So you can see here, I grab my OWM object, so that's just my connector to connect to Open Weather Map. Then I take the result of the get OWM IDs by state, so this is just a list of, here I'll show you real quick so that it's not just all esoteric. And I did provide a string, even though the only data in there is Utah right now, so. Oops. Oh yeah, that's right. Okay, 1 second, sorry. We'll cover that in a second. Shift insert, there we go. We'll cover that in a second too. I basically make a special connector to do database stuff. String has no. Okay, so this is again the problem you get when you live code. So I'm not going to show you that it gives you a list of, but you're going to have to trust me that that gives you a list of Utah OWM IDs. So then the next thing I do here, for each one of those IDs in that list, I get the current weather by ID. So this is just another function, ID. Yeah, and it's like super duper simple. It literally is just calling one of the functions that exist inside of the OWM object that we created earlier. And then this is where it gets a little bit more fun. So this script takes that OWM object that we just pulled from Open Weather Map, and it retrieves the weather and the location objects. And from that, and you can see this is the part where I just went ahead and did all of this for us. So again, you can find this code on the repository that we have. What we're going to do is we're going to make an object, and we're going to insert that into the database. So I'll segue now into talking about the database. So if you're new to Python, or maybe not new to Python, but you haven't done databases, SQLite 3 is part of the core lib. That is a built-in database that has no listeners, there's no complexity to it. It's literally just a database file, which is awesome because listeners are a pain in the neck to set up, and if you're not used to dealing with that, like, it adds a huge layer of complexity that you probably aren't going to need. SQLite basically just takes it's just a collection of flat files, and you point it at a file and it makes it into a database. So what I tend to do is, and this is, if I'm going to deal with data, this is basically the first thing I do. I make that database folder and I put something called database.py in it, and I put models.py in it. So I use SQL Alchemy. SQL Alchemy is basically object-oriented data, or object-oriented databases. So you can query your database with objects, you can query your database with SQL. It gives you the ability to do both, but it's really easy to use in Python, so that's what I do. And so in database, Presentation mode. Yeah, so let me explain that. So you can see this create connection string. If you are dealing with Postgres or, God forbid, Oracle or something like that, this would be a lot more complicated. You'd basically have to be passing it what ports you're using, and obviously the ports would have to be open. You're going to be passing it, well, actually, with an instance of Postgres, you're going to have to actually convert it into a different URL type object. With SQLite, the os.path.expand user is just home directory in Linux. If you're on a Windows machine, it'll be your documents folder. And then I've just created openweather.db. That's your database. Beautiful. So then the next thing is I do a get connection, so that returns my connection string. And the reason I do it this way is because if you do ever want to switch databases, it's a lot easier just to change this path out or comment it and make a different return. Then the third function that gets called here is the SQL Alchemy connect, and you can see here that it's just calling that the connection string we're making. And then, yeah, so in SQL Alchemy, we have an engine object. And so this is what actually talks to the database. And then you have a session objects, and this is the object portion of it that interfaces with the engine that we just talked about. So let me go down a little bit. I will call this function at the top in py.main, or in whatever my main file is. I'm just going to pass this thing around. Let me go to main here, main.py. Yeah. So yeah, I can't reach there because I'm short, but engine comma session. You start that at the top of whatever file it is that you're doing, and then you pass this around into the various parts of the project. Because if you don't, well, you can do it that way, but if you basically will know when you're supposed to not do that, and up until that point, you should probably do it this way. What'll happen is you'll get conflicting connections with the database, and so you'll actually be like potentially causing deadlock with yourself, which is not a fun thing to try to troubleshoot. But if you pass these objects around, that can't happen because you're only connecting to these two instances at any given point in time. And then with models, let's see where to go. Okay, and so here, if you go to the Open Weather Map website, you can see all of the various, their data structure that they're going to be given back to you. This is just a normalized version of just the current weather data. And so I would actually go out to Firefox, but I don't want to figure out how to do Alt-Tab on i3. But basically, if you are going to be doing anything with data and you don't know much about it, the Wikipedia articles for normalization are actually excellent, excellent resources. Read through basically up through third normal form, and you're going to be able to do like 90% of any data stuff. So the basic idea with normalization is you're going to be taking data and putting it into something that actually organizes it mathematically. First, the joke that you're going to see on the Wikipedia is something to the effect of, the data belongs to the key, the whole key, and nothing but the whole key, so help me COD, because Boyce Codd is the person who developed normalization. So awesome pun. So let's implement that. So what I've done is I
did a joke for Ferris.
So if you read the documentation here, it's basically gonna give you a giant spit out of weather data. What I've done is I made one that is just weather event, and so this is going to be the city ID and the reception time that we received the data in. This is the reason that you're doing something like this is because you don't want to overwrite data. So let's say that you were to just base this on like the city. Well, then every time you get new data, you just overwrite the data for that city. But we want to keep the data every time we retrieve it. So that's why, well, okay, let me back up there for a second. Let's see here. So I really wish I. All right, Ferris, how do I get into Firefox or just a browser? It would really help if I could just see the data model. Technical difficulties, sorry.
No worries. Which?
Any browser. I just need to go to the documentation so I can show you what you'd get.
What did we put you, 9? Oh, okay, so we'll put you on 8.
Okay.
So we just use
Perfect.
8, 9.
8, 9. Oh, that's easy. I can handle that. Ah, beautiful. So this is what I was going to show you earlier. So if you go to a website, they usually have pretty well documented API. So we're going to go to the weather data doc. Ah, beautiful, the API response. So this is what you're going to get when you query the weather data. It's a JSON object. In this case, we're going to get objects specifically. So we're going to have like .getWind will give us that wind JSON object. So here we can see we're going to get the coordinates for our location. This is why I was saying it doesn't do states, it just gives you coordinates for reasons that I have no idea. The ID is going to be the weather specifically, so 800 is clear. Oh yeah, clear, it says right there. Then you're going to get a more specific description. You're going to get temperature data, minimum, maximum, so on and so forth. So what we're going to do, and what the data model does, is it takes this object and it saves it for every instance for every city. So with normalization, you're going to get, where's the city ID? He's down at the bottom. Count at the bottom. Oh yeah, perfect. Yeah, so here we can see that 185.1632 is for, oh goodness, Shuzhenji, and the time is 32400. Oh no, that's time zone. We have time here somewhere too. DT. This date object is the date that this applies to. Why is it a giant integer? This is called epoch time. So this is the milliseconds I think, since 1970 in GMT. And this is a pretty standard way of handling data. So you're going to get this type of response quite a bit actually if you deal with data, because it's easy to store this in a database. So what we want to do is we want to take this ID and this date, and all of the other attributes of this JSON file are going to be dependent on this. So this is what we call a primary key. Primary key basically means that you can't have this value more than once. So if we made 185.1632 the primary key, if we tried to insert all this other data, every time we had a new datetime object, it would overwrite. Similarly, well, obviously, if we had just the datetime and we updated, we'd only have one time point because it would just overwrite every single ID that we got. The other thing that you might want to do, though, is even if these are your primary keys, is add what's called a surrogate key. And that's what I tend to do. Function 9. At the top here, weather event ID. This is mine. This is not something you're going to get. And the reason that you add this auto-incrementing primary key is if you ever do anything else with the data, this uniquely identifies a row solely by itself. I worked with medical data for the better part of 3 years now, and this is almost never done, and it makes things a giant nightmare because there's all sorts of validation problems that you get, or like, oh, this is a 12 terabyte data set and it only was able to insert 75%. Good luck figuring out which 75% it was. So for long term, I highly recommend doing this. Well, then how do you make a primary key? You can see at the bottom here, I've put in a unique constraint. This is not all that a primary key does. A primary key also in most databases gives you what's called a clustered index. So it actually sorts the data physically on the hard disk, which is optimized, awesome. So this doesn't give us that. We can also put null values here, which you can't with a primary key. And in some cases, this is good. Let's say that we didn't get a date object, but we know the city. That would kind of be a silly example in this case, but there's lots of instances where you might need like that permutation to be unique, but you don't have one of the attributes. A unique constraint with an auto-incrementing primary surrogate key avoids that issue. So, and there are other ways that we can add a null constraint and that sort of thing, but we don't need it for this, so I didn't put it up there. So the other attributes here are just things. This is the part about it that is, and only the primary key, so help me COD. Everything here is dependent solely on the city and the date that it was received. But there's some stuff that you're going to note in the object here that wouldn't make sense. So if we update the whole database or each city 5-6 times a day, there's only one sunrise and sunset per day, hopefully. So that's not dependent on the time that you're retrieving it, right? So what I've done here is I made another table that is just dependent. I call it sun schedule for lack of a more creative name. Again, we have an auto-incrementing primary key, and we have the date that it was received. So we're only getting one sunset and one sunrise per day per city. So that's what that unique constraint does. Let's see here. And then I think the final thing is, yeah, so then the other thing is just locations. And again, I won't talk about this just because it's kind of a pain in the neck to get to that point. I've already done the work for us, so we don't need to do that. Okay, so then the last thing that we do okay, so then basically what we're doing here, this object that I'm creating, so weather event equals m.weather_event. What I've done at the top here is I've imported that models file from the database. And this is where it helps to have that just in a separate location. It's very easy just to get all of your database objects in the same place. And one of the cool things about using an IDE is if you're doing this, oh, what do you know? Autocomplete. It tells me what tables I have up there. If you're using something, well, actually, I think Jupyter actually does do this now. Yeah. But this saves so much time, just being able to use autocomplete. So highly, highly recommend. At any rate, so this object has all these attributes now, and I really won't go through these because it's relatively self-explanatory. Basically, you get your weather object and you get a location object. So here's your weather object dot get snow. I'll give you a hint, we don't have any. Get wind, and then, so this is just assigning whatever it is from the API to the table column that we're going to have. And then the last thing you do is you insert it into the database with that session object that we created earlier. Session.merge takes, a class, one of the models that we made, and inserts it into the database, and then commit actually saves it to the database. So if this commit isn't here, this is something that this will catch you up if you're not used to using a database. And I know that because when I first started using databases, I spent probably 5 hours trying to figure out why nothing was getting inserted. I wasn't committing anything to the database. I was inserting, and then what will happen in a database is until you commit that transaction, nothing gets saved. Or actually, more accurately, it gets rolled back. So like 10,000 foot overview, the reason you do that is for ACID compliance. So atomicity, there's a couple other things, but the basic crux of it is when you insert something, you want that whole query to finish, because if it doesn't, then you end up with the database in an inconsistent state, and that's really bad. Really bad, because then you don't know if the data is right, you don't know which data is right, which data is wrong. Half the time you don't have an auto-incrementing primary key, so you can't even figure it out. So bad stuff. So session commit saves that.
Where is session defined?
It's a parameter.
Session, yeah, so that's in database. Oh, and I didn't go into presentation mode, so you can't even see it, my bad. So we created this with the connection to the SQL Alchemy. Session is the thing that connects the object mapper to the engine. So connection string is the first step. Then your engine actually physically connects to the database with that connection string. The engine can actually send raw SQL files. It can send statements to the database. It's actually really quite powerful what you can do with an engine. But then the session is going to it's going to take the classes that you make, and it's going to let you interact with the objects or with raw SQL. So what we just saw here in the module here, this is a class. And so if we didn't have that session object, this would just be nonsense to the database. So this converts it into like SQL on the back end. And actually what's cool, and I can't demonstrate it because I The if name main is broken. I haven't figured that out because live coding sucks.
Yeah.
But if you print weather event here, it's going to give you a raw SQL string, which is awesome for debugging. Usually, there's some other interestingly enough, on a side note, if you use Postgres and you try to do giant, large bulk inserts, highly recommend checking out Mogrify, because otherwise it's going to do individual inserts, and that will take you forever. Don't ask me how I know that one.
I'll show you faster ways too.
Yeah, there are other faster ways of doing it too, but that's one of the quick and dirty ways of getting that running. So,
is there, sorry, I just want to see the database file. I think there's an auto commit flag.
there is.
Yeah.
Yes, so you can do that too in the database.
In your session maker, right?
Yeah, so right here, I've set auto flush to be false, but you can set that to be true, and you can also set auto commit to be true. Flushing is when you assign these primary surrogate keys that I've been adding. If you didn't flush the database, so yeah, I guess I can get into that because I'm almost done here. Right here, we could do a session.flush, and that would assign keys, and then at the end, do a commit, and that way everything would be considered one giant transaction. And there are reasons you'd want to do that, and it's basically boils down to, do you want this one big transaction to fail? If something's wrong with it, that way you can back it out and not have to worry about like, oh crap, what data is right, what data is wrong. And so the end result of this, what did I do? Oh, I see. Because I'm not executing the main file. Yeah, there we go. All the weather data for Utah at this moment. So yeah, feel free to, like I said, download the repository and play around with it if you want some weather data or you want to, have some live data. And this is really one of those things where intermediate people, I see a lot of times on Reddit and stuff like, what should I do now? Like, I know Python, but I have no idea what to do with it. Well, this can give you some idea of what, you can do with at least some of the weather data, and then maybe you make an application that, oh, should I wear shorts today? Well, if the forecast for today is greater than 73, then it's a shorts day.
Oh, sweet. We can integrate our two presentations. We have a decision tree.
Whether or not we should wear shorts.
You could do one of those one-off websites that like, should I wear shorts in saltlakecity.com?
Yep.
Just yes.
The future of that domain is bright.
Yeah.
Indeed. Well, yeah, so that's basic API utilization.
All right.
And a little bit of normalization.
Sweet. Well, that's our meetup for the most part, except we have some giveaways to do. Let's do that right now, shall we? Boop. Boop. Sound effects are very important to programming.
There's an add-on, there's a Python module for that. What is it? No, a PyCharm add-on.
What, where it makes like computer sounds? A PyCharm add-on that makes computer sounds.
No, it's when, what is it? When you get errors and stuff, there's like explosions and stuff on the
Oh,
screen.
sweet.
I don't remember what it is now though.
I need
It's
to
a real
blow.
thing, though.
I'd love to blow PyCharm some more. That would be great. Random. So what number will you get to, Maria? Okay, who is missing a name tag? And there were two out in the back. Does somebody want to grab there's like 25, 26 name tags over there? And then, oh sweet, here, I'll grab that. Throne tag. What numbers are on there?
24 and 25.
You're 26. This will be 27. Who's 24 and 5? You two. You're 24 and 5.
24.
Oh, you're 24.
Yes.
Okay, you're 25, 26. Off by one, it's a thing. And then anybody else missing? You are 27 then. That's your number. Wait, you're 26? 27. 25, 26. What are you? Okay. You're 27 now. 28. Okay.
29.
Yeah, you're 29. Okay. We're really bad at this. We're pair programming, right? So, what did we decide? How many are there?
29.
29? Is that what we decided? That there's 29? You're all wrong. There's 30 because I started with 0. Ha ha!
Did you really start with 0?
I did.
Oh boy.
It would help if I actually had my num lock on. But because I started with 0, we'll do that, which is ridiculous, I know, but see? No magic variables except 0. Does this look good to everybody? Can I merge this PR? Got approval? All right, so again, if your number gets called, you get to pick one of these 4 lovely prizes. You also get to hit enter and pick the next person. You cannot win twice. Okay. Number 14, congratulations. John. Machine learning, you want to hit enter? 11. Isla, yay!
She already won last time.
Hold on, let me just seed state to. No, I'm just kidding.
I already have this book and it's awesome, so I'm
Yeah,
gonna take this.
sweet. Do you want to hit enter for me?
Yes.
It's right there. Boop. Number 8. Number 8. Yay! All right. You get to hit enter. Last drawing. Boop. Number 13. Matt. Hey. Here you go. That's all we got for you. We'll see you on the, what did we say, the 4th? At WeWork, Building 6. I will send all kinds of directions to everybody, but I am telling you it'll be at the gateway. Parking is going to be 100 times easier, I'm hoping. Should be free. Everything I heard is free. So, and yeah, should be a fun experience. Hope to see you all there, and yeah, see you in a month. Have a good August.
Thank you. Google Power Mode 2 pie chart. How's it going?
Bye.